Oh, no, he doesn't. Otherwise, it would have showed up on history.
So I'm
I
saying-
can use mine, Professor.
Yeah, I can use yours because yours is complete actually,
Yes.
and I don't have to do anything.
Yeah, John's also complete as well.
Right. Okay.
Or we can use
You guys can please take notes. I'm going to show you something that will help you. Basically, it eliminates the step that you are on right now, where you are showing, where you are going to be loading. What is it called?
Is that what you need?
Yeah, I need so. That's what I need. So when you are here, your schematic is complete, labels everything, right?
Mm-hmm.
Then you basically, you guys know to save design and check and save design, that's fine. And of course you would see the prompt if anything. Then when you go to, I think it's tools, SAE, which is the step that's outlined, you have that step. So in this step, we don't need to go out anyway and save files and do anything else. On this step, there's a menu here. There's a session menu. If we already have a state that we saved, we can load it. We don't have one right now, so we don't have to worry about that. Setup is the important one. That's really the important one that you want. So we know our design name, we're not worried about that. We know the simulator. We want to perform an analysis. That's the first thing that's important. So here we are going to click on analysis. Which analysis do you want to do? Is it transient? Is it DC? Or is it any of these? What were you guys going to do? Transient or DC?
If we look on here, it go down
transient.
was
Transit. Okay. So what I'm going to show you while I'm here, what I'm going to show you is going to avoid you doing
all the editing of the entire net list.
right. So it's going to basically you will stop here. You're not going to do much of what you did here, much of what you did here. You will have no need to invoke CosmoScope. You won't need CosmoScope at all. And we're going to simulate all of that. Right? So we're going to do that, skip those steps, and do all of this. So this here is important. We're going to need this later on. Right?
So transient and DC is what we need.
Where am I? Back here. So transient, sorry, you guys want transient first, right?
Yeah, transient.
So transient. So in transient, the start time is 0. The time step, yeah, we can make it 1 nano. 1 n is enough. And for me, I'm going to allow this thing to go for 40 nanoseconds. I mean, I'm not following what you have been given. So you guys type this information as given. I'm just going to do 40 nanoseconds for my simulation. UIC says use initial conditions. I can just click that OK, that's fine. And we'll do OK for that. So that's analysis. Your analysis, whether it's transient, whether it's DC, whether it's .op, whether it's AC, you can select it there, right? We'll do OK. The next step, again, under setup. So there are 3 things to set up. Next step is the model, right? In the previous file, you are told to type a long path. Here you don't type that path. You just go, we're going here and add. And then here we're going to basically select users is what I want. I'm going to come here and go to home, the slash, right? Then I have users, should be able to find you. Yeah, users, synopsis. I need IPDK90. I need, then I click on that. Then in this directory, in this IPDK directory, I need spice, HSpice. I click on that. Then I say choose. Yeah, choose. That's the directory I want. Then I'm going to click to add file. And I'll click on there. And the file that I want is there. That's the file I want. So I will open that. This is the path you have in one of your handouts. That's the path USR, synopsis, IPDK90.
Yeah, it's on.
Right. You have that path. But that's what we need. However, here, you'll notice that it says BJT_12. You want to click on that and change it to TT_12. That's that. For every design you do. In fact, if it's a layout, once you do this in one layout library, you never have to do this again. It's already known where your libraries are, right? So we are only doing this once, the setting up. Once you set up in the same library, you never have to do it again. But if you employ that other method, you will always have to do it every time you run Synopsys. So let's do OK for now. So we have done the analysis.
Setup analysis.
We have done models. Now we're going to do include files. But before we include files, we can go, let's go here.
Which one are you going to?
I need MobaXTerm actually. So here, I'll type gedit with the ampersand sign. Just I'm going to give my file a name, gedit, and the name of the file is going to be header.txt, just a text. Doesn't really matter. You can give it any name of your one. Any name.
Gedit space is not required.
Gedit space, then the file name, whatever file name. Because I don't have a file created already, I'm creating one right now, and I'm going to put the ampersand sign. Ampersand sign gives me this window back if I have to use it again. So it gives me that. My file is empty. I have nothing, right? What I need here is basically a header file. I'm running transient, right? So here I'm going to basically do. Oh, how do I edit? How come it's not editing? I don't know. And I'm going to do inverter. Let me just say header file instead of doing inverter. Header file. The header file is nothing more than just some of the parameters I want. For example, the first one I'm going to call it VA. VA is going to be VDD, exclamation mark, and it's going to be from 0 volts to 1.8. Is that 1.8 you guys are using? No, you don't.
No.
It's
Well,
not.
I haven't
I don't.
been there yet.
You have.
I have. That's ahead of me.
Okay. So here, basically what I'm entering here is this information. This information, where I said power supply, so I'm entering this information. Right? That's the information I'm entering. So I need the VDD. I can call it VDD. That's fine. VDD exclamation mark. What else do I need? I need the. I don't need the options. I don't need that. And I think I can. The analysis is already okay. The only time I'll need that is, yeah. The rest is fine. Yeah. So the only thing really I need is VDD. Just in my header file for now, all I need is to define VDD. That's all. I can define GND, I believe. Yeah, I can define GND. This comes by default. It's generated by NetList. So the only thing I need for now is just that. Right? So back to my gedit. Instead of doing VA, let's just call it. It's okay. Call it VA. That's fine. Do I need anything else? Let's do VB, and I'm going to call that GND exclamation mark, and I'm going to call it 0. I'm going to call it 0. So these are the values. So what I'm doing here is that I'm defining my power supply voltage to be VDD. Each time I have VDD, 1.8 volts is the maximum VDD will go, 0 is the minimum. Each time I have GND, 0 is the minimum it can go, 0 is the maximum it can go. For now, let's just save this information. If we have an error, we'll come back to it. But assuming I have no error, I'm going to now go back to here. Don't know which one I want.
MobaX or
That's the one I want. So in this window now, Remember, we did analysis, we did models, we're now on include. So the file I want to include, I'll click to add file, I'll select here. That file is called header.txt. I need
Probably
to
move
find
it.
I'm sorry?
Would it be to the right?
I don't know, I have to find it.
Oh, there it is, header.txt.
That's the file I want to include. It has my parameters about VDD. Right? So I'm clicking OK. Then I'll come here, set up again. So I've done include, there's nothing else I need. Right? So if I look here, variables, I don't have to worry about variables. Outputs, then I can select in design. Okay, select in design. That actually should be here. So this is my output that I am interested in. I'll click it. This is my input that I'm interested in. I'll click it. So you can see they're highlighted. If I go back now to my circuit, the output is selected. I should actually state it's an output. Should I? I don't know that. So they're there. There's in, you call it in underscore SDV?
Yes,
So
because they said for the initials, we have to put in our initials.
Okay. So now in my file here, there's something I have to do. I'm going to do V1. You called it in underscore
SDV.
SDV. And to define what it is, do you want in underscore SDV? I'm going to call it a pulse. And it's going to go from 0 to 1.8, and then am I right? I think it's pulse 0.8. I might be wrong there. Then I think it's actually pulse in parentheses. Starts at 0, goes to 1.8. It's got a 0 delay. It's got a rise time of, let's say, 10 nanoseconds, too much. A rise time of 5 nanoseconds. That's too much again. Let's just go to 1 nanosecond. A rise time of 1 nanosecond. A fall time of 1 nanosecond. A pulse width of 20 nanoseconds, and a period of make pulse width of 10 nanoseconds, period of 20 nanoseconds. So here I have defined in my include file, I have defined my input. That's going to be my input. Right? It's a pulse. It starts at 0 volts. Goes up to 1.8 volts, has no delay. It takes 1 nanosecond to rise, 1 nanosecond to fall, with a pulse wave of 10 nanoseconds, and it repeats every 20 nanoseconds. So I save that. I don't know what, I can't remember what
The out?
this specification has said. So really what I'm describing is this guy.
Okay.
It's called VIN in 0, oh sorry, 0 pulse. Yeah, 0. So I didn't worry about that.
So this V in right here has to match what I have for mine.
No, this is VIN is equivalent to
Oh,
my
okay.
V1.
Yes.
What matches your case is in. In
So
must be in underscore STV.
STV.
That's what matches your label. So this matches your label. This here is equivalent to my V1. This here is your label. Then these are the parameter descriptions. So this was made very short, 2 nanoseconds. Mine is a lot of time. Right? So we're done there. We go back. It's not the one I want. We've selected that. That I don't think so. Basically, we're not going to need this anymore. not going to need that anymore. Right. So here we have told our system what our outputs, we have selected them. Then when we come to simulation, we do netlist and run. Instead of doing create, we're going to do netlist and run. And then we'll click on that. So it's running. If it passes, we're not going to see this guy. Right now it failed. It basically says we have an extra numerical data found. Check the syntax. Line 4. Difficulty in reading line 4. Correct. So line 4, 1, 2, 3, 4. It's this guy. So I'm not sure why.
Did you need parentheses?
I did. This is one. There is another one. So I don't know what I've done wrong with my line 4. V1 in underscore SDV. It's a pause. 0.1.8. This if you look at this, except for the 00 that they have here, let's compare 20N, 20N. 0, 1N, 1N, 10N. That's line 4. So let's go back here. In underscore SDV. Yeah. Okay. There's an error I have. I'm yet to find out what it is. So let's go here. Yeah.
Oh, extra numerical data found.
Data found.
So I think that means I have an extra number.
Yeah, but it seems like my statement is all correct, so I don't know what numerical data I have. 0, 1.8, 0. All this information should be there. I mean, what is extra? Just 0. Let's try that. That should not be the issue though. Close this. Bring this window back up again. And try again. That was the issue. So immediately, as you can see, instead of you loading CosmoScope, I have my output right away there, right? So I have a long delay. I'm running for 40 nanoseconds. My 10 nanosecond delay is very big. My 1 nanosecond delay is very big for this, right? So what we can do with this, basically, obviously this doesn't look, it's unsightly, right? What we need to do is probably let's not quit this window. Let's leave this window as it is and go